Hey guys, this is Xavier with Notebooks.com. I'm here with John Taylor of AMD. We're talking about graphics today, watching some movies, and playing around with some new notebooks. This one is from ASUS. It's going to be announced in just about a month in time for Windows 7. And what are we looking at here, John?
So Xavier, this is our second generation ultra-thin platform. And what we're doing is, this is actually one where ASUS has elected to include an optical drive. So we're actually using the optical drive to do playback, do an upscale of the movie to HD resolutions, but as you see, because of the graphics capability in the platform, the use of our universal video decoder block, we're seeing the CPU not working very hard at all, despite even the upscaling and the enhancements to the image itself, which means you get a better visual experience and you get longer battery life while enjoying it, which is what we call an active battery life scenario.
So if I look at that CPU utilization, it looks like it's bouncing between about 10 and 20% while we're watching the movie full screen. And this is not a speed demon of a processor, it's an efficient processor, and that's why we're relying more on the GPU here.
Correct. This system has a 1.5 gigahertz dual core in it, so we're not throwing a whole ton of CPU at the problem. We're throwing, in this case, GPU at the appropriate task for the GPU. You know, as we move towards these very video intensive, entertainment intensive scenarios of how people use notebooks, understanding the role that the graphics play in giving you the better experience is something that demonstrations like this are really effective in doing.
Now, this is important if people want to do other stuff on their PC while they're watching a movie, or to save on battery life, I assume?
Yeah, absolutely. So in this case, you know, we've got other tasks going too while we're even doing this. You've got headroom to go, say you wanted to go into Windows mode and check your email for a moment, do something different with some other application. You've got ample headroom to use the system for other purposes, or you've got the confidence that you could, again, be watching a DVD off of an optical drive and be sure that you're going to get to watch that whole movie because the whole system isn't working very hard to play it.
Now, besides watching movies, a lot of people like to make movies now. People
yeah, absolutely.
Their iPhone 3GSs or their video phones and flip videos and whatnot. And shooting video is easy, but getting it to work with your PC isn't always the most fun thing in the world, to say the least, right?
Yeah, that's correct. So one of the things that there is to be excited about with what some of the application providers like Cyberlink or Microsoft are doing themselves with Windows 7 is making it much easier for consumers to do things like this. So this is a 1080p HD video file, but it could just as easily be a 720p file that I shot with a pocket cam that I bought for $150, maybe an hour of film of my kids playing soccer. So I can now just drag it into applications like this, or with Windows 7, use some of the features built into Windows 7 to do this drag and drop type scenario. You see it's dropped into my application, and this Cyberlink Media Show Espresso then allows me to do things like port it over to popular Apple, Sony, or Microsoft devices, or what we'll do is say we've decided to share this video that we've shot on YouTube with the rest of the family. It pulls up automatic YouTube resolutions, and what's new is we've got this little button that tells us, do you want to take advantage of the full resources of the platform? Of course, it defaults to that to make the job as quick as possible for the consumer. But if I click it off, what you'll see is if you rely on just the CPU, this process of taking a video from one format and making it work online like in YouTube, it takes roughly 1-to-1. For every second of this 1080p clip that we've got, we need at least a second of transcoding time to use it on YouTube.
So this isn't so horrible because it's a 30-second clip, but as you mentioned, if you videotape your kid's soccer game or piano recital,
right,
you're going to be sitting here all night.
If you have an hour of footage, you'd be sitting there for an hour or longer as you work to get that uploaded online.
And that doesn't include uploading, so once you're done transcoding,
you have more time to go. That's correct. All right, so that took about 34 seconds.
And that was starting with a 30-second clip, so
just 34 seconds with a 30-second clip. So if I do the process again using the same click, come back up, I want to upload it to YouTube, but I allow the application to use the default, which is to throw the resources inside this AMD platform at the problem that make the most sense. Don't just use the CPU like some would. Use the GPU as well as the CPU in addressing the transcoding challenge. So I'll say, okay, again, I'm just leaving the defaults on. The consumer wouldn't even have to think about it. And what you'll see is instead of the 34 seconds that it took on this 30-second clip before, we're now going to get it done in roughly a little over 20 seconds time. So it's wrapping up now, and we'll save, in this case, 10, 11, 12 seconds or more. What you've got to do then is compound that, 21 seconds time versus 34, compound that to an hour of video footage, and you've just saved yourself 20 minutes, 30 minutes of time on this task. So the GPU in this case is much better suited to accelerating the task than throwing lots more CPU at it.